and of course, cheapest insulator. So in between, you put can, so that when you do the experiment, when you put hot water inside, the heat will not go out that easy. Will keep containing. So who using this technology more often? Ladies and gentlemen, it's called construction. Especially lately, you probably, if you own a house, a lot of people try to sell you something called window, specialized window. What kind of specialized window? It's something like this. This is a glass window, and then here is another glass side window. This is a window, and here is a window, glass window. In between here is called air. Especially in the East Coast now, they're using this kind of setup. Why? This is air is the best insulators, so that the heat will not get out. So this kill inside and the get out, kill outside. It's not that easy to get out. So consequently, we're using this approach. Ladies and gentlemen, there's another thing is very important for us, is how to apply heat. Okay, they call heat application. 17.4 section, we call latent heat. And the phase change. What we try to tell you is heat is poison. Of course, right now in the cold weather, heat is your friend. I will tell you the story later. And, this is a very important story. There's one of the British pressure is a student call. So I will tell you a long story about the students. 16 years ago, I teach one student, and lo and behold, he called me from Taiwan. He says, "Do you remember me?" I said, he said, "I'm in Taiwan now." He was my student 16 years ago. I didn't even recognize his face. Anyway, call me. And then later on, we talk about the heat. We will tell you another story about the students have in danger with the heat. Okay, so heat is poison. It can kill you as well can burn your fingers. Okay, so that is. Turn out is not the fire, turn out to be the steam going to burn your fingers, that kind of stuff. So what that means? Means if you have something like this, keep heating up, heat up. This one, if this is a solid, if you keep heating up, and then it will become liquid. If you keep heating up this one, then it will become what we call gas. Okay? So between this is called phase change. From solid to liquid, liquid to gas. That means the heat can change a material phase. So we like to say from solid to liquid, we have to inject certain heat. Heat of fusion is stand for L sub F. That means you use what they call at the melting point. At the melting point, then the solid will change from solid to liquid. That's called heat of fusion. And then if you keep adding heat in here, in these cases, the liquid will change into gas. In which cases, we have a good name called L sub F. It is called heat of vaporization. Okay, so that means they have in generally we like to using water or liquid water, and then from water it change to steam. That's why the first industrial revolution, Mr. Joule is utilize the steam to generating the power for the locomotive. So we like to use water as example. Water is a very specialized matter. Water is a very important ingredient for our life. It has a certain characteristic we will mention as time goes by. So in the horizontal version is called energy. You input the energy to the system, in which cases, in these cases, it is related to the heat energy. So the vertical we like to indicate is T sub C, temperature. So we like to say from minus 30 degrees Celsius to 0 degrees Celsius, and then to all the way to 100 degrees Celsius. Okay, so for example, we're using two temperature points as cases. So from minus 30 degrees, you will keep giving energies. So this giving energy. So hitting the melting point. At the melting point, we keep increase energy to that called L sub F equal to 80 calorie per gram. Then if you have enough 80 calories, and here is still solid ice, and you go up to here, then at this point, you change phase. This point change phase that have enough energy to make the ice become liquid form right at this point. And then you heat up the temperature again, it go up. Now go up this time, of course, obey the Q equal to MC delta T. And then at this point is called the vaporization point. Then if you keep on giving energy, this energy to the water turn out to be LV. Look at LV is equal to 540 calorie per gram per gram. Ladies and gentlemen, look, 540 calorie per gram, 80 per calorie per gram. So what does that makes the difference? 7 times, almost 7 times the heat energy in here. So after this become gas or steam. So ladies and gentlemen, this steam is powerful and poison. The first way we like to talk about as far as that goes, 17.4. 17.4 is talking about the work done by the gas. So you need to go back. Chapter 16, work in thermal process. Thermal process. How does the work is being done? Okay, so the work is being done by gas. By gas expanding. When it expanded, then it will push the piston up and down, up. For example, what we're talking about is something like this. It is a cylinder with crows and have a lever arm on the top. This is called piston. Basically, it's automobile. So, and this one have a P and V in here. It means pressure and volume. And when this thing heat up by external mean or internal mean, heating this up, then this thing will move up. So suppose that this is a V sub I, this is P sub I. So P sub I, and then P sub F, and B sub F, and expanding. But this piston is doing the work. Piston. So here you go. You have some pushing up. Is the pressure. Pressure is pressure move this piston up. Pressure. Pressure move the piston up. Okay, so let's review what is the work. Work is related with F times X. Suppose like this, the F is going down here, and this is the Y. Changes or delta Y. And this is the area. It's constant. Area A. This is the area A. Okay. So when this was moving up, so that the work is equal to F times Y. Okay. Now that is equal to, because there's some pressure there. Assume the pressure is constant, then this one is equal to force equal to pressure times A times Y. So in that case, A times Y is volume. So P times a volume, pressure times a volume, is give us the work. As far as that goes, is related with work joules. So in these cases, we like to say